Good day, my name is Snježana Maksimović. I come from Faculty of Architecture, Civil Engineering and Geodesy as part as the Key Force project. Today I will speak about qualitative and quantitative statistical methods in risk management. So let's start it. The plan of the talk is following: introduction, the probability theory, statistical methods, the case of the study. During the last 2 decades, there has been a growing awareness that our world only has limited new renewable natural resources such as energy and materials, but also limited renewable resources such as drinking water, clean air. Sustainable development is defined as a development that meets the need of the present without compromising the ability of future generations to meet their own needs. So, design and operation of civil engineering infrastructures are clear. Save energy, save non-renewable resources, and find out about recycling of building materials, do not pollute the air, water or soil with toxic substances, and much more. A beneficial engineered facility is understood as being economically efficient in serving a special purpose, fulfilling given requirements with regard to the safety of the personnel directly involved with or indirectly exposed to the facility, fulfilling given requirements to limit the adverse effects of the facility on the environment. Based on these requirements, the ultimate task of the engineer is to make decisions or to provide the decision basis for others in order to ensure that engineered facilities are established in such a way as to provide the largest possible benefit. Example: feasibility of hydraulic power plant. A hydraulic power plant project involving the construction of a water reservoir in a mountain valley is planned. The benefit of the hydraulic power plant is associated only with the monetary income from selling electricity to customers. The decision problem is to compare the cost of establishing, operating, and eventually the commissioning the hydraulic power plant with the incomes to be expected during the service life of the plant. It must be ensured that the safety of the personnel involved in the construction and operation of the plant and the safety of third persons. There are many factors which are important for the building of the power plant. Selling electricity will depend on the availability of water, which depends on the future snow and rainfall. The market situation may change, and competing energy resources such as thermal and solar power may cause a reduction of the market price of electricity. The more the capacity the power plant will have, the higher the dam and the larger the construction cost will be. As a consequence of dam failure, the potential flooding will be larger. The safety of the people in a town downstream of the reservoir will also be influenced by the load-carrying capacity of the dam structure. Risk represents product of consequences and probabilities of dam failure. Both consequences and probability vary through the life of the power plant. Carefully planning during the first phase of the project is the only way to control the risks associated events. Errors, mistakes, accidents, human errors, failure of structural components, extreme load situation, natural hazards. Questions: how large are acceptable risks? What is one prepared to invest to obtain a potential benefit? The mathematical basis for such decision problem is decision theory. If we have one event with potential consequences C, then the risk R is defined. R is product of consequences and probability. If we have n events with potential consequences CE, then the risk R is defined as sum of consequences and probabilities. Theory of probability. Probability theory deals with the study of phenomena whose results cannot be predicted. The foundations of probability theory were laid by Cardano and Galileo studying gambling, and Pascal and Fermat the laws of gambling set on a mathematical basis. A random experiment is an experiment in which, independent of the performance condition, different outcomes occur. A set of all possible outcomes of an experiment will code the space of elementary events omega. Elements omega in omega we call elementary events. Every subset A of omega we call an event. If a set omega has finally many equally possible outcomes, then, definition, if M is the number of favorable outcomes of an experiment A, subset of omega, of a random experiment omega, and N is the number of all possible outcomes of that experiment, then the probability of an event A is defined M divided by N. Random variables. When we perform an experiment, in addition to the outcome of that experiment, we register the value of a function corresponding to that outcome. To the outcome of the experiment, we assign a real number. Depending on the experiment, sometimes the outcome it can be a number, for example, throwing a metal coin, and sometimes it is not the case. Definition. A random variable is a function that assigns a real number to each event. A variable, such as the strength of a concrete or any other material or physical quantity whose value is uncertain or unpredicted, is a random variable. We have two basic types of random variables: discrete, when x of omega is countable, and continuous, when x of omega is non-countable. Definition. A discrete random variable is a function that takes values from a countable set x1, x2 with probability p1, p2. We can write that in the following way. The most commonly used distributions of discrete type are binomial distributions, Poisson distribution. Distributions of continuous type. A random variable that can take any value from an interval AB is called a continuous random variable. Definition. A random variable x is a continuous if there exists a continuous function f such that f is non-negative for every x and integral from -infinity to infinity f of x dx is 1, by which we can express the following probability. Function little f is a function density of distribution. A distribution function big F is a primitive function of density little f. The most commonly used distributions of continuous type are uniform distribution, exponential distribution, normal distribution, logarithmic normal distribution, gamma distribution, chi-square distribution, students' t distributions. Basics of mathematical statistics. The study of random phenomena implies the possibility of measuring various data, statistical data. The task of mathematical statistics is to choose from registered data the probability which the best describe the accidental phenomena being observed. Definition. A set omega considered in mathematical statistics is called a population or a general set. A function that every omega in omega assigns a real number is called a feature, and it is denoted by x, y, z. Example, the population is a set of product of one factory. The feature of each product is, for example, its price. It is often complicated to register a feature for each element of the population, so we register feature only on the one part of the population, which we call sample. The statistical study of some feature involves 3 stages: statistical observation, grouping and arranging data, processing and analysis of results. The observed feature can be qualitative, binary. There are 2 choices, example smoker and non-smoker. Ordinary. There is a hierarchy, example level of education. Nominally, no hierarchy, example nationality. And can be quantitative. If the sample has a large number of elements, we arrange registered data and display them graphically. If a feature is a discrete registered data, we grouping into classes, and with continuous feature, registered data is grouped at intervals. How we graphically displayed a qualitative feature? The usual choice is pie graph and a bar chart. How we graphically displayed a numerical feature? The usual choice is dot diagram, frequency histogram, box plot, and line diagram. Definition: let x1, x2, xn be a simple random sample of population with a feature x and a function f. A random variable u is f of x1, x2 till xn is called statistics. The most important statistics are mean value of sample, variance of sample, repaired variance of sample. Sample is a realization of n-dimensional random variable. Parameter t is a realization of a random variable big T. Example: statistics mean value of sample is an estimation of expectation, since statistics repaired variance of sample is an estimation of variance. Based on the sample, we estimated a parameter t, so estimations can be dotted estimation, for example, maximum likelihood method, interval estimation, for example, confidence intervals. Statistical tests. An application of statistical methods in laboratories and manufacturing facility is associated with conclusion about: does analytical method have systematic errors? Do 2 measurements method differ in accuracy? Which of 2 technological process is better? So we want to make conclusion about parameters of basic set, mean and variance based on the sample. Any assumption about the characteristic of the basic set expressed in the form of a statement of distribution, one or more features, is called a statistical hypothesis. At the beginning, we set a null hypothesis H0, the hypothesis to be tested. The opposite hypothesis is an alternative hypothesis H1. Definition: the procedure for testing of null hypothesis based off a realized sample is called a statistical test. We will consider 2 types of hypotheses: parametric hypothesis that represents an assumption about the value of someone from the parameters of the known assumed distribution, non-parametric hypothesis representing the assumption of the type of distribution population, determination of dependence, 2 or more features, equality testing. Procedure of testing a parametric hypothesis is called a parametric test, and non-parametric hypothesis non-parametric test. The critical area, C, is the set of all those points for which hypothesis H0 is rejected. By the type of critical area, statistical tests are divided into one-tiled and two-tiled. If a realized value of sample is in critical area, then null hypothesis is rejected. An acceptance of hypothesis H0 based on the sample from the basic set does not mean that it is correct, it just means that the sample does not contradict the hypothesis. By testing hypothesis, there is a risk that the conclusion of the test is incorrect. Type 1, H0 is correct, but based on the sample is rejected. Type 2, H0 is not corrected, but based on the sample is accepted. We often choose for the null hypothesis the one for which the data suggests that be rejected, because the rejection is usually more reliable than acceptance. The most commonly used parametric tests are Z-test, T-test, analysis of variance, test of hypothesis involving the variance. The most commonly used non-parametric tests are Pearson's chi-square test, Kolmogorov-Smirnov test, Mann-Whitney-U test, Kruskal-Wallis H test. The case of study. Housing units of two Banja Luka settlements were analyzed, Česma and Budžak, which were flooded in May of 2040, total 38 housing units. A survey questionnaire was created, which was filled by the inhabitants of these settlements, population data, plot size, distance of the object on the plot of the riverbed, height of flood damage. The distance of this object in relation to the river was also analyzed, flooding and damage that occurred. The obtained results were presented through the descriptive statistics and adequate statistical test in the analytical software package SPSS version 23. Figure shows rainfall data for months March, April and May during the period 2040-2019 in the territory of the Banja Luka city. The highest rainfall fell in April and May 2040, and it is interesting to note that in May 2090 there was a greater rainfall than in May 2040. In our sample, 35 housing units were flooded in May 2014, of which 8 housing units were flooded multiple times in the last 10 years, while only 3 housing units were not flooded. Table shows that in the observed sample, the most objects are on the plots of size from 300 to 500 square meters, 17, and the 7 objects are 0 till 50 meters and 7 objects 51 till 100 meters away from the riverbed. In our sample, there is 1 housing unit on each plot. Considering the size of plots by settlements in the observed sample, the most plots are 300 till 500 square meters, that is 41.4% in the settlement Budžak and 55.6% in the settlement Česma. Large plots were only in the settlement Budžak, 3 plots in total. The estimated amount of damage in the Česma settlement averaged 20,926 and in the Budžak settlement 50,857. Looking at the amount of damage per settlement, no statistically significant difference was obtained between the settlement Česma and the settlement Budžak. Also, we conclude that half of the population living in endangered areas are partially informed about flood protection measures. By the opinion of the survey population, 24 believe that the state has not taken the necessary measures to protect against flood. There was no answer yes. Thank you for your attention. If you want to contact me, my mail is at the end of my presentation.